Now that we've learned about free radicals, we'll move on to free radical substitution. It's easier to understand concept via examples. And the most famous example of free radical substitution is halogenation of alkanes, and more specifically chlorination of methane. So let us begin by understanding that. There are 4 steps in the reaction of chlorination of methane. The first one, methane reacts with chlorine in the presence of HNu and high temperature to give you CH3Cl plus HCl. Now the CH3Cl, which is a product in the first reaction, again reacts with more chlorine to give you CH2Cl2 plus HCl. Now CH2Cl2, the product formed in the second reaction, again reacts with more chlorine to give you CHCl3 and HCl. As you can see, the H in the alkane is being replaced by chlorine. So this is a substitution reaction. And in the last reaction, CHCl3, which is the product of the third reaction, reacts with more chlorine to form CCl4 and HCl. So these are very simple basic reactions which happen in the chlorination of methane. But there is a very interesting mechanism which happens behind these reactions. Now let's study that mechanism. So there are 3 steps in the mechanism of chlorination of methane: initiation, propagation, and termination. The first, where the reaction is initiated; second, where the reaction is carried out; and third, where the reaction ends. The initiation step is the step where chlorine free radical forms. In the initiation step, chlorine in the presence of high temperature and HNu gives you chlorine free radicals. The initiation step is very important, guys, and it is asked in a lot of competitive exams. Another thing to note here is the organic molecule, in this case methane, is not present in this first step. This step is only about the generation of free radicals of chlorine. It does not give any importance to methane. So please remember that this is a very important step for exams. A lot of questions are asked on it. So just remember, in this step, only the generation of chlorine free radical happens. The second step is the propagation step. In this step, the chlorine free radical which was generated in the previous step is used to create the 4 products of chlorination of methane. So all the 4 products which we talked about, which happen in this reaction, are produced in the propagation step. So the initiation step was only about the generation of the chlorine free radical, and in this propagation step, we will form all the 4 products of the chlorination of methane reaction. First, the chlorine free radical generated in the initiation step reacts with methane to give us methyl free radical and HCl. Then the methyl free radical reacts with more chlorine to form our first product, which is CH3Cl, and give us one more free radical of chlorine. It's not at all confusing, it's really simple. Methane reacted with one chlorine free radical to give us a methyl free radical. That methyl free radical reacted with regular chlorine to give us CH3Cl and one more chlorine free radical. And this is how all the 4 products are formed, just like this. So the reaction continues the same way until all the 4 products are formed. So now we'll see all the reactions of the propagation step in one place. First, as I explained, the chlorine free radical generated in the initiation step reacts with methane to give us methyl free radical and HCl. Now the methyl free radical reacts with chlorine to give us our first product, CH3Cl plus chlorine free radical. Now CH3Cl reacts with chlorine free radical to give us CH2Cl free radical plus HCl. So the CH2Cl free radical reacts with chlorine to give us CH2Cl2, which is our second product. Now CH2Cl2 reacts with chlorine free radical again to give us CHCl2 free radical. The CHCl2 free radical reacts with more chlorine to give us our third product, CHCl3. Then CHCl3 plus chlorine free radical give us CCl3 free radical, which reacts with more chlorine to give us CCl4, which is our final product. And the chain propagation stops here. So these are all the reactions of the propagation step. I know the propagation step can be a little confusing, but if you understand it in a logical way, you'll realize that it's very, very simple and easy. To make things a little more simple for you, we've listed down the takeaways from the propagation step. Point A, there are 8 total reactions in the propagation step. Very easy to remember. 8 total reactions in the propagation step. Point B, in every odd numbered reaction, that is the first, third, fifth and seventh reaction, the alkane reacts with chlorine free radical to form alkyl free radicals. Okay? And in every even numbered step, that is the second, fourth, sixth and eighth reaction, the alkyl free radical, which was formed in the odd numbered reaction, reacts with chlorine to form one of our products. And thus the 4 products of chlorination of methane are formed in the propagation step. Now we move on to the last step, which is termination. Now all the products are made, so the last step is chain termination. This stops any further production of new free radicals. So all the free radicals react together to stop further reactions. Chlorine free radicals react together to form chlorine. Free radicals of methyl and chlorine react together to form CH3Cl. And methyl free radicals react together to form C2H6, which is ethane. Therefore, we have studied the mechanism for halogenation of alkanes. Here it is important to remember the reactivity order of halogens, where fluorine F2 is the most reactive, followed by Cl2, then Br2, and then iodine, which is the least reactive. So another concept which comes under free radical substitution is allylic bromination. What is the allyl position? Now everyone keeps talking about the allyl position. You must have heard your teachers or your friends refer to it. What is the allyl position? So let's see an example. CH2, double bond CH, single bond CH2, single bond X. That X is said to be the allyl position. So anything which is at position X is said to be at the allyl position. Okay? So you can see the position, the allyl position from the perspective of the double bond. A special reagent NBS, which is N-bromosuccinimide, is used to brominate at the allyl position. What is the meaning of the word brominate? That is, introduce bromine. So please remember this, a special reagent NBS is used to brominate at the allyl position. We've also written down the formula for NBS for you. Also another thing to remember is NBS can also be used where allyl position symptom occurs, where it is similar to an allyl position. And NBS is also used for benzylic bromination. We'll see examples of these points to clarify them further. First, we'll see an example of allyl position bromination. So CH2 double bond CH single bond CH3, which is propene, plus NBS brominates at the allyl position. So what is the product? Propene has 3 carbons where bromine can attach itself. So reaction A, B and C show you the 3 positions where bromine can attach itself if that free radical forms. Now in all of these 3 reactions A, B and C, A refers to the allylic position reaction. And as we know, NBS introduces bromine only at the allyl position, and so the answer will be A, which is CH2 double bond CH single bond CH2 Br. So propene, when it reacts with NBS, the answer will be CH2 double bond CH single bond CH2 Br. As we've already stated, NBS can also be used for benzylic bromination. What is the benzyl position? Now, as we've explained the allyl position to you, let's understand what the benzyl position means. So as you can see, we have made benzene, then there's CH2 attached to it, and whatever attaches itself to that CH2, that is the benzyl position. So that carbon is the benzyl position carbon. This bond, whatever attaches itself to this carbon, will be at the benzyl position. Now let's understand benzylic bromination through an example. We have toluene here plus NBS. In the presence of heat, we know that the Br will attack the benzyl position and attach itself there. Let's see another example. We have ethyl benzene plus NBS. Now there are two carbons which are attached to the benzene, but we know the benzyl position, and so Br will be introduced at the benzyl position only. In both the above examples, Br attacks the benzyl position and bromine is introduced there. The next question is for you to solve. We have cyclohexene here plus NBS in the presence of heat. What will be the product formed? Could you solve it? Let's understand. In cyclohexene, you cannot see any benzyl position, right? There's no carbon attached to it. So how will we solve this? Let's make the structure of cyclohexene. After making the structure, as you can see, the CH2 double bond CH single bond CH2, that part seems similar to the allyl free radical position, right? So therefore, Br will attack at the allyl position here. If you remember, we had already told you that if allyl position symptoms are present, then also NBS will introduce bromine there. So this is that situation where it looks similar to an allyl free radical, and so Br will attack at the allyl position. So cyclohexene plus NBS in the presence of heat, the bromine is introduced at the allyl position here. That's all, guys. We've gone over all of the main and important points of free radical and free radical substitution and broken down the concepts in very easy and simple to understand formats for you. We hope you could understand this concept. If you have any doubts, you can ask them in the comments below. Thank you so much for watching this video. If you like the video, please hit the like button, subscribe to our channel. We'll see you next time. Bye bye.